Nickels and dimes may not be a lot, but bundled together, they accumulate and compound over time, delivering long-term value that make a lasting impact. RavenDB has been running for over a decade, developing hundreds of features, both big and small. The big ones, like distributed data, ACID over multiple documents and throughout your cluster, automatic indexing, and adaptive learning-based documents compression, make a huge difference. The lesser-known features accomplish two objectives. One, they enable you to put together a powerful system by simplifying things that are hard in transferring the complexity of certain tasks onto a database that just works. Things like polymorphic data types, the ability to index multiple collections in one shot, to project and massage data as it comes out of the database are great examples. Two, they boost your productivity. For example, the ability to automatically maintain index definitions as you work with your code, to version your application in the database state in the same manner, to enable multi-versioning when you have two versions of your application working against the same database at the same time, to greatly reduce the overhead you have to deal with when you are involved in complex deployments. Today, RavenDB CEO Oren Eini will explain all of these features in depth, showcasing one by one how each feature works. Leveraging these features can increase the ROI on your application significantly and deliver continuously increasing value to your users. Feel free to ask questions by clicking the Q&A button at the bottom of your screen, and Oren will be happy to answer them throughout the session. Enjoy your presentation, and here's Oren.
Hi, everyone. Thank you for coming to this webinar. And it's interesting. I've been working on RavenDB for over a decade. And like David said earlier, there are some big ticket stuff, the stuff that we always talk about. And then there is stuff behind the scenes that just work, but can make a huge difference to the system. And it's interesting because the first hidden feature that I have to show you is this one, the session. Now, it's really funny that I say that the session is a hidden feature. The session is how you use RavenDB. I mean, this is the absolutely most trivial example that I can think of using RavenDB, and here's the session. So how can I say that this is a hidden feature? It's a hidden feature because you aren't using its capabilities. And just to give you something that really, really upset me, people write code like this. And I'm looking at that and I just want to scream. And why? Why are you doing something so absolutely horrendous? So let's talk about why this is bad first. And the reason this is bad is because what you're doing, you're losing the unit of work, you're losing change tracking. So let me show you something really trivial. Before I started the webinar, I went ahead and created this document. And I did it using this code. Now, what I'm going to do this, s.load, and that's about it. That's okay. I'm going to run this now, and this run, it will work, it will process. I will go here and I can see that the data has changed. What's so interesting about this? Why am I explaining about this? Well, if you think about that, this is actually a really important feature. It's actually also a very complex one. Because what we're saying here is that RavenDB, the session, is going to manage change tracking for us. That means that when I'm calling save changes, every document that was loaded in this session is going to be inspected for changes. And if it change, we're going to send it right back to the server, updated. What happens here? What happens here is that you created the session, use it, and then it goes poof. If you want to save this value back to the database, it's on you. You're the one who has to manage change tracking. You're the one who has to manage optimistic concurrency. Oh, by the way, how do I manage optimistic concurrency with the session? I ask it, use optimistic or correct. Now I'm done. In here, remember to get the change vector, remember to send it, remember to do a whole bunch of work that I see people are doing for absolutely no reason. For that matter, there is another major problem here. Let's look at this and say that I have here and I'm going a bit recursive in this case, but I have this, and now so it bugs me that it's not properly formatted. Okay, so now I'm going to do this. And what's going to happen now? So I'm going to say what do you expect to run? What we're actually going to get is something really interesting. Well, why is it B? I set it to A. Well, as it turns out, user and reference are the exact same thing. This is because the session is a unit of work. When inside the unit of work, all the references to a particular document resolve to same reference in memory. And that simplifies your logic by a lot. Consider what happens if you have to use this. In this case, you're using different session every time you call get. In this case, it's on you to figure out what happened if you accidentally had a cross-reference. Okay, I can tell you that I've written the internals of RavenDB. I work with an Hibernate. Those are absolutely not things that you want to do in your business application. It's annoying. This is me reading code like that because I'm just sitting there thinking, I spent so much time making convenience features, making it easy and available for users, and let's just throw it away and build it again. It's deeply frustrating. Anyway, the session is the primary mechanism to use RavenDB. And even though most people don't use the unit of work with the change tracking all the time, there are also a whole bunch of other features that we have available for you. So evict and refresh, let's talk about what those mean. Evict is very simple. It's I want you, remember that in here, let's do something fun. What I'm going to do now, I'm going to stop in the middle of the operation. So now I can see that the user, the name is set to B. Let's go here, and now the name is set to C. Notice that I'm loading the same user right now, but I'm going to get the same reference, and I'm going to still get it to B. Why is that? Because the moment that I made a query, the moment that I loaded a document in my environment, I'm going to keep that version of the document. Why is that? I may have made decisions based on the properties of this document. So I can't go ahead and change it behind your back. And now I'm going to do this, and this will fail. This should have failed. Why wouldn't it fail? Oh, I know I didn't fail. So what happened was that I changed it from A to B, but it was already B. So the change tracking didn't trigger a call to the server. So we didn't know that the value changed behind our back because we didn't change it in our code. Let's try it now. In this case, the value is C. I'm now going to try to change it to D. And now change to A, change to B. And now it's going to fail, concurrency exception, blah, blah, blah. Which is the exact thing that I expect. Now, I can also do this. I can also say evict. And let's see what will happen now. What evict does, it says, I want you to forget about this instance. So right now we have D, and I'm going to store it now as E. Now let's load. And what you can see that reference is now set to E. At the same time, the user is set to D, the old value. And if I'm able to see the console somewhere, here we go. No, that's not it. There we go. So now I can see that this returned false. So what evict did, it told RavenDB, I want you to forget about this instance. And then we try to load it again. When we load it again, we go to the database again. We're not familiar with that because we forgot about it, and we get a new instance of the object. There is almost never any good reason to use that, except when you really, really have to. What might be more interest to us is not to use the evict, but to use the refresh. And to use the refresh, we need to say something like this. I loaded the document. I have reason to suspect that it has been modified behind my back. I want you to apply these modifications. So let's see here. Now we're running. And the value that we have right now in memory is E. Change it to F and run this. And now the value is F. Notice that in this case, again, they should have been the same. Huh. Oh yeah, okay. So refresh created new instance. I did not expect that actually. So I need to look into why I did that. But the whole idea is that if you're not trying to mess about. So here's something that happened. It looks like we created an instance because of this, because of the refresh. This is actually probably a bug, but when that happened, we had two instances wired to the same user ID. And then we are able to, but then we're trying to save, but we have optimistic concurrency and we fail. So the whole transaction itself has failed completely. Now, the last thing that I want to talk about is what changed. And what changed is a really interesting feature. Let's look here. Remember that I said that the system does change tracking, the session does change tracking? When it does that, something really interesting happens. We're able to access this change tracking. And I expect it to be able to run now. Oh, if you're not running that, it will not run. And when things change, I can start inspecting the in-memory changes. So the field change, and I can see that we switch from A to F. You can do all sorts of interesting things with this. You might want to write, okay, here are the list of changes that happened, and the person who changed them was Joe. Okay, you know what? Let's go ahead and implement that, because this is another hidden feature that we have in RavenDB. That feature is called events. Oh. On before store. Now let's see what's going to happen here. I'm going to run this. And I don't actually recommend doing that. What's the problem? Oh yes, I need to translate that into this is actually document changes, and this is an array of document changes. Okay, so array. And I'm using very low level API here. Don't necessarily have to do it this way, but from that's it. Now I can do something like this. Hopefully that will work. If not, I will learn not to do dynamic demos on the fly. Yay, now it worked. Now you can see here are my changes. They're not pretty good changes, but they are changes. Should have done it like this. But makes sense anyway. So this is interesting. This allows me to do a lot of stuff dynamically. I have actually quite a lot of those events that you can make use of. I really love this one. This allows you to do something before each query. I spoke about it in my previous webinar, where you can use this event to say, oh, only do that for a particular tenant. You can use this to configure all of the session in a particular way. For example, let's say that I want to say all of the session must have a optimistic concurrency enabled by default. So this is how you do it. On session. And now we're done. In the same sense, by the way, we have a whole lot of features around here to customize the way that RavenDB behaves. And the good news about that in 99% of the cases, you don't have to think about that. Those are options that are there to serve the one-off cases where, oh, I don't have to strip down RavenDB to its part. I can go here and plug this behavior or that behavior. We mentioned doing polymorphic operations. Now, when we talk about polymorphic operations, there are two types of people who learn polymorphism. There are the people who learn with shapes, so rectangle, rec, circle, and square. There are people who learn with animals, so you have pet, dog, and cat. And there are the weirdos who learn with cars, trucks, and motorcycles, something like that. I'm not considering those. But honestly speaking, they're typically 45% of the people, these 45% of this, and the vehicles is a very, very small minority in the how you teach polymorphism. So let's talk about how you do that in Raven. Let's do pet. I like pets better. Okay. So now what we're going to do, let's just kill this that we don't care about. What we're going to do, we're going to say, let's even do this like this. Okay. So now s dot store and now I have give me a cat name, Mr. Snuggles, whatever. Okay, so let's run this code, see what happens. And in a few seconds, you can see that I have dogs and I have cats. And now I want to run a polymorphic query. What just happened? So let's do this. Query. Now, what do you expect this query to run to give us to get us back? We're going to get 0. We have no match for pet because there cannot be any collection called pets because pets is abstract. If pet weren't abstract, this query would run something like this. There are no pets here. So how do we fix that? It's in here. So store.convention.find collection name. If type of a pet. So let's do it like this. And I always get confused about is assignable form. Let's see if that would work. That should not work, but give me 0. Why it gave me 0? Because now I'm actually running this. So let's try this again. Now I'm saving the dog and the cat again. And now I'm going to see something quite interesting. Here I got pets. Both of them together, by the way, in the same collection. And if I'm going to run this query, I will always get 2. Now it's getting interesting. What happens if I want to say, give me dog? I will also get 2. Why is that? Because we told Raven, when I'm thinking dog, I'm actually thinking about the collection pets. But what happens if I do this? Now I'm going to only get 1. Why is that? Because I'm actually using only one of them. Because only dogs have bark. I can go into more complex systems. In some cases, I would have something like this. Which would allow me, obviously, to do filter on the real types. Come on. And now you'll be able to see that I'm using this. I'm able to store. Now we can see that this is a dog. We can also query using this, but this is slightly more complex to query on a normal basis. So let's talk about other options that we have. The typical model that we have for modifying documents is load them, modify in memory, call save changes. This is what we always did here. You also have the options of running patches. Every actually has strongly typed patches that you can run to this API. Add items, remove items from arrays, from dictionaries, set properties, those sorts of things. You can also do this. And note that in this case, you have the complete freedom to write whatever you want, including more complex scripts. Oh, I want to take I want to run a patch that would update the record based on some other record and do computation. Go ahead and put it here. Now, there is something really important that we have to understand about patching, about RavenDB in general. The session is transactional. That means that everything in the session is going to take part in the transaction. So these two operations, they're going to run as a single unit. When I'm adding a defer to a session, it's going to run in the same transaction all of the other changes that happen in the session. And that's absolutely something that you want to take advantage of. You can also use this. Instead of wanting to say, oh, I want to update a particular instance. In the case of patch, we update a particular instance that we deal with. In this case, we have update by query and delete by query. From the studio, stuff like this. And if you want to do delete by query, you can just click here. And it will ask you whatever you want to do the actual deletion. Now, a few interesting about this. First of all, it makes it very simple to do all sorts of schema update, migration, those sort of things. That allow you to run all sorts of interesting logic. At the bottom, you can see how we can do delete by query. You can see that we can even use strongly typed link to process the queries. Now, we have a problem with this approach. What happens if I'm trying to delete 100,000 records? A deletion is an expensive operation. I might, the classic example is what happens when a user cancels their account. I have to go and delete all of the data. The problem is that I might be running I might be running under load, and suddenly having to clean up a whole lot of data is very expensive. So I can control that. I say, don't rush too fast. Run and stop, run and stop. I don't want to put too much load on the system. Now, something really important about update and delete by query, they are not transactional. They are running multiple nested transactions that are not conjoined to one another. So if this fails in the middle, it is going to modify some of the data, but not some of the other data. Another thing to take into account that this returns an operation, which means that the server accepted your request and has started executing that. Not that it is done executing this. This is being ensured here. Okay. Now, RavenDB allows you to run queries of any size. In previous version of RavenDB, we had a limit of how much you would can set the page size on queries. and people complain about that like crazy. So in RavenDB 4.0, we don't have a limit, but we still have a very strong recommendation. If you need to query lots of data, and lots of data is in the, let's say, 5 megabyte or higher, you want to use streaming. And why do I want to use streaming? Because streaming does a few things that are really interesting. On the server side, we are starting to send you the result as soon as possible. We're not trying to bundle them in memory before we send it to you. On the client side, we start processing them immediately. So you can start pulling the data directly from the system. So let me show you how this looks like. So what this returns is IEnumerator. So I can do it like this. Now, what's important about this behavior is that while I'm it's very likely that I'm processing the first result here before the server finish sending me the result of the request, because the assumption is that we're dealing with very large result sets. So the server starts spinning it out as soon as possible. The session starts spinning it out to your code as soon as possible, and everything aims to reduce the overall cost, to reduce the amount of stuff that we have to keep in memory, all of those sort of things. We can also take it even further in some cases, and you can see that I'm just saying load into stream or load starting with into stream. What's the idea here? The idea here is that instead of, in the most common case, what you would do here, you would write it somewhere. So just give RavenDB the stream that you want to write. In most cases, that would be the output, the response stream for the request. And Raven will just push all of that directly to it. No need to parse the value, no need to do anything in memory, just immediate handoff. Now let's talk about caching. Caching is an interesting feature in RavenDB. It's on by default. And let me show you what I mean by it's on by default. Let's take this query. And let's run it. But let's go here and look at the traffic watch. And what I want to see just queries. So let's run it. And hopefully we're going to see 3 query here. I would appreciate to see the 3 queries here, please. 1, 2, 3. No queries. That's interesting. Here we go. Took a while. Now, notice the queries are the same, but the results are very different. You can see that the first one gave me 200, then 304, 304. 304 stands for not modify. What this means is that, even this trivial amount of text is actually using caching. What happens is that we read the false query from the server. And let's see how that looks. Here the result of the query. And this is the e tag of the result. Next time I'm going to run this query, the tag is going to remain the same. So I'm taking advantage of that and saying, oh, when I'm sending the result to the server, I'm going to actually send it with the previous tag. In which case the server can avoid doing anything. There's actually an optimized code path to check, oh, am I in the same state that I was when I ran this query? And if so, I can just tell you 3 or 4, you're good. Use your cached version of the data. That reduces the amount of data that you send down the line, that reduces the amount of memory that you have to deal with. So it's good all around. And I mentioned that this is on by default. There are ways to turn it off, but there is almost no case where you want to do that. Something that you have to be aware of, look at this query. Is it going to be cached? And the answer is that no, it's not going to be cached. And why is that? Because we have a date. Okay, actually, this one will be cached because we're using the date. But if we had just datetime now, I'm sorry, I missed that it has a date component. If we had a datetime now, then it will not be. Because every time you call datetime now, you're going to get a new version of this query, which is obviously something that you don't want to. So in many cases, when you're using queries with dates, what you want to do, you want to be able to say, oh, I want to flatten the query to a per minute, per 5-minute granularity, something like that. We also have aggressive caching. Aggressive caching says, oh, remember the part where I told you to go to the server with the data and make sure that nothing changed? Don't bother going to the server. You can just assume that the data didn't change for the next 5 minutes. We actually register to get notification from the server about that specific feature. But in most cases, you say, oh, I just want to avoid running this query too much. We also have the notion of lazy queries. And it's funny, most of the hidden features that I'm going to talk about are around reducing the load, reducing the number of service round trips, those sort of things. So what you can see here is that we're saying, okay, let's get lazily. Let's get some document lazily. Let's get the user lazily, something like that. This doesn't go to the server. What's actually happening is that it registers the request and saying, oh, I'm going to run it at some other point in time. Let's look at the actual code and do this. So what we're going to say, advanced lazily load. And that's how it works. I'm going to run this now. And let's go back here. And here. What this is going to do is absolutely nothing. We're being lazy. No query sent to the database. However, if I did something like that, so the result of this is, oh, sorry, this is not async. So I can do something like this. Now what's going to happen? And now what's going to happen is that the moment that I access one of those, I'm going to say, oh, I have to go to the server. Here's what happened. I went to the server once, but I went to the server with 2 queries. So I reduced the number of round trips that I have to deal with. And that is a performance killer. They're going over the network. I just cut it bit by however much I needed to. You can also do this explicitly. Just pass the raw results out if you want, but you get the idea. Another good example of how we can reduce the number of round trips is the use of includes. As includes basically says, oh, you know what? When you load for the orders, look at the companies or the employees and make sure that you grab the related items as well. And you can see here how it goes. We're getting 830 results, 53 companies and 9 employees. And that's important. That's important because now when I need to access that data, I don't have to go all the way back to the server. I can process that immediately. Let's look at that. Let's go ahead and use the users. Okay. So now we're starting from pets. Oh, in this case, this is a dog. So let's see how that would work. Include dog. And load. What is your problem? I'm pretty sure this is. Oh, sorry. This is a string, not this. Yeah. Okay. So now this works. And now I'm going to say as well as. So let's see what's going on now. I'm saying, give me the dog. This I intended to say, give me the dog. Line 33. This should work. Yep. That should definitely work. Let's see why it doesn't work. That's interesting. Because, sorry, this is stupidity between keyboard and chair. Now let's run this. And now it works. Why does it work? How come this is a single request to the server? I load it up into the session using the include. When I'm saying load, I'm getting it back directly from the session. I'm reducing the number of times that I have to go to the server. Other fun features. Index creation, especially when you're running on developer mode. You make a change to the system, you rerun it, you put it on startup, it creates property indexes. For fun, some of the features that RavenDB added in 4.0 is the fact that every single time you add an index, it is done on a side-by-side mode. So you made a change, you start the application, the old index is still there, still functioning. The new index is chatting in the background, creating itself. It will only switch when you actually need it to. So that makes things a lot simpler for upgrade, moving, those sort of things. Now, let's talk about something annoying. I have a okay. So I added a property. This is a new version of the system. Now, and let's do something like this. Notice what we're doing here. We are loading the document, which doesn't have a color property. We're modifying it and we're saving it back. The problem is that we don't have the color property, so we are expecting to have some issues here. But the value was maintained. It was round-tripped. Notice that we have no problem with a rename. We have no problem with missing properties. We are keeping additional properties as we go along. Everything just works. And you can focus on building your application. Finally, we have this idea, the ability to map multiple indexes, multiple collections at the same time. The one rule that we have is that they must have the same structure. But beyond that, go wild. And that allows you to do some really interesting queries. Of course, many collections, many environments. Conversely, by the way, what about pets? So if I'm going to look here, these are the pets and look at bugs. But this will actually go over the cats as well because they belong to the pets collection. So this is another way to do polymorphism. And now is the time for questions. I will try to go over features that aren't discussed all the time. Features that are important to your system, to how you're running, but don't have this kind of make or break decisions. But they do have a huge impact on quality of life almost. You can hit the Q&A button to ask questions. In the meantime, we are very near the release of RavenDB 5.0. Hopefully, we're going to make the release sometime this week. We had a transaction leak where we held a transaction too long in some specific scenario, and that means that the fix itself was easy enough to do, but we now have to do the longevity test from scratch, which is obviously naturally taking time. But we are on the cusp of making this release. The big features for 5.0 are time series, document compression, whole bunch of smaller features that are really interesting. If you want to go into more detail, there are a few webinars that I made that go into what's going on with 5.0, time series, compression, those sort of things. You can also schedule a demo with one of our engineers and we'll go over your exact scenario, location, what you need, what's going on, things of this nature. I don't think there are going to be any questions. So thank you very much for showing up for this webinar and have a great day. Goodbye.